Hello, in this video I'm going to go over a nice homing missile script that I developed for a 2D space scroller shooter. I'll start off by just playing the game and demonstrating what I got going on. In this game I just have some randomly spawning asteroids. My primary weapon is just a straight-on laser shooter, but if I press 2 on the keyboard my lasers become homing missiles. And you'll notice how each missile picks out a new target. If no targets have been found, or if asteroids have already been marked true but have been occluded by another asteroid, then no targets will be selected and the missiles will just fly forward. So now you notice the missiles are just flying forward until a new wave of asteroids come, and then they start tracking the asteroids. Some of the nice benefits about the script are each missile targets a different asteroid, so you don't have all the missiles just racing towards one asteroid. Every missile finds its own unique target. Alright, so how did I do this? Well, let's go over some of the components I've set up for my assets in the game. Right now, on my player, you can see I have a whole bunch of components that control movement and fire. The biggest one we should look at right now is the player weapon fire. I have two game objects, one for laser, one for missile swarm. A fire mode switches between the two. I can set the fire rate and the missile fire rate for both laser and missile. Alright. Then, if we go to my prefabs that are instantiated throughout the game, I go to my asteroid. A very important component on here is targeted script, and by default it's set to false, so when asteroids are spawned they are not targeted. Is targeted is not checked. Alright, the meat of the whole homing missile script is attached to my missile prefab, or my swarm missile. Missile right now just goes straight. Swarm missile is what I've called my homing missile, and you'll see I have a script attached with a public variable where I can set the speed of the missiles. So let's go ahead and open up my homing missile script. You can see I have all the code here, and they're commented out for easy readability and for learning purposes. These are all the variables I have. I guess I'll go through everything real quick. I'll try to be quick. Missile float is a public variable. It's a float. Missile speed, this allows you to change the speed of the missiles. The rest are private variables because all the code is just going to be handled within the missile script, and I don't need to pass any of these objects off or variables off anywhere else. I have a game object that'll hold the closest target, which in this case, in the example I just showed you, is an asteroid. I have two vector scripts right here that hold vector positions or distances, distance difference and player position. These player position is actually the 3-point coordinates of the actual player you're flying as, and distance difference figures the vector math between the player position and the asteroid that you're shooting at. These two floats right here measure distances. An old distance that holds the value of the last asteroid you checked, a current distance that holds what you're solving for at the moment. Private game object, this is my hazard array, so whenever the missile is instantiated, we'll go down to the awake function. Right on awake, I chose to put it in awake because as soon as the missile is instantiated or shot by the player, I just want the array to be created and cycled through only once. First we got to set old distance to math infinity. This ensures that the oldest distance that you're going to start comparing to is pretty much the biggest number you can get, which is infinity. So this gives you a nice starting point to start comparing distances to. Player position, right here I use game object find by name, and transform position gives me the vector values of where this player is currently when you're shooting your missiles. Here I instantiate the hazard array, and I use it by find objects with tag. and my asteroids are tagged as hazard, so I could make debris and mark them as hazard, and it would do the same thing. It would find both debris and asteroids at that time. So after I instantiate my array and find the position of my player and set a value for all distance, I need to go through a for loop that cycles through every single asteroid in the array that I created right here. Alright. In this for loop, we create a throwaway counter variable I and set it to 0, and then we got to figure out how many I guess entries into the array there are, how big's the index or how long. We use hazardarray.length. This gives you an integer value for how many objects are in your array at the given frame in which the missile is instantiated, and then we just increment the value by I. I is really nice because as we know, arrays are accessed with a bracket. Right here, you can see right here, there's a bracket. If hazard array bracket 0 bracket was called, it would give you the very first game object in the array. So with our for loop, I is being incremented by 1 each time. So hazard array is going to be 0, and then the next time through it's going to be hazard array bracket 1 bracket, and so on and so forth. So our for loop will start by finding the distance between our two game objects when we want to compare, which is going to be the player and the current asteroid or hazard within our array. Since distance difference is a vector right here, we have to do one more step after we figure out the distance difference, and we have to basically use the square magnitude of this vector to give us a float value that we can then set to current distance. And current distance is going to be able to be compared against the old distance. So after we figure out the current distance of the asteroid we're checking within our array, we need to have a if statement within our for loop. Alright, so we need to check 3 things in this if statement. We need to check if the current distance is less than the old distance. That means if the asteroid we're checking or the hazard we're checking now is if the distance is less than the old distance of other asteroids we've checked, that's good because that means it's closer. We also need to check and see if the asteroid has been set to targeted or not. I access the asteroid by using this get component script. So it's basically saying in the hazard array at position I, which we'll consider this as the start of the loop, so the 0 position in our array, we're going to check that asteroid, and then we're going to get the component, which is basically the is targeted script I've attached to it, and use this syntax exactly here. And then we want to find a attribute connected to the opponent that is targeted I showed you at the beginning. If this is false, then that means the asteroid is not targeted yet. So we can keep going with the if statement, and to make sure that missiles don't fly out the back of our ship, because that's really not the kind of behavior we're going for, we're going to check the player's position in the Z axis and make sure it's less than the hazard array position in the Z axis. And I put a minus value of 5 just to make sure that missiles can't go straight up. There's always going to be kind of a an area in which the missiles are going to have a believable angle. So just comparing the positions between the asteroid and the player. So if all 3 of these conditions are true, then we have a winner, and we need to do a few things. We need to set the closest target to the asteroid in our array. If we need to set the old distance to the current distance, and we need to go ahead and turn that asteroid's target into false, or if it's false, we need to turn it to true. So basically, again, this is me accessing the is targeted variable on my current asteroid, denoted by that I there. And if it's false, if it equals false, then we're just going to take that same value that you saw right here and set it to true. This way, if it's set to true, then this part of the if statement will pretty much be false, and we won't go into this if statement again. So basically, that's going to give us a game object that we're going to assign closest target to. So this whole cycle It's called once. We don't want to have it in the update or update function because we don't want to be cycling through the array constantly. That just wastes instructions. So to get the asteroid or the missiles to actually move, we have to go to void fixed update because we're using rigid bodies, and rigid bodies depend on physics calculations, and physics calculations really need to be set in stone and steady. So fixed update is nice because it doesn't rely on frame rate to be computed. So if you ever have a dip in frame rate, it's going to screw up your physics calculations. Void update is just the one that relies on frame rate, but we want to use a constant update for our physics. First thing we need to do is we need to check and see if there's even an asteroid that's targeted or able to be targeted. So if you're in between waves and there's no asteroids on the screen, it's going to allow you to just fire your missiles forward. That way, if you press a button, something will happen and you won't be locked out of firing your missiles. But if we do have a target, that means the closest target is true because there's a game object assigned to it. Then we do 2 lines of code. First, we do a transform lookat, and this basically allows you the missile to point towards the object. If it was stationary, it would just kind of rotate on its axis, but look at whatever target we have specified. The closest target transform position will give you the position of that target. To get the missile to actually move, we're going to use a vector 3 move towards function right here, and we're going to set 3 different values to this. First, we need to find the position of our current missile, and we need to compare that to the value of where we want to go, which is the closest target dot transform dot position, and then we need to give it a speed or a time in which it travels. So you just use time delta time and multiply that by your public missile speed variable, and that should give you a pretty good homing missile for all intents and purposes. This really depends on having components set on the different prefabs you have in your scene, but I kind of went over that in the beginning of the video. Alright, thanks. It's been a real pleasure working on this, and be sure to check back for other little tips and tricks in Unity.